females. Not really. Here, let's take a look at that. So here's what I want to do. Let's color code the genders. Okay. So we're going to do some more formatting. Go to home, conditional formatting. Let's make a new rule. Okay. What is that noise? Wait a minute. Let's not do that. Greater than this. Equal to. Maybe. Do you guys have this where it has greater than, less than, between, text that contains? Let's try text that contains. Okay, classic. Format only cells that contain specific text containing, let's go, capital F. And let's do custom format. Is everybody at kind of this window? Everybody still with me? Good. All right, let's go with, where's the fill? There it is. Oh, it's already up. Pink for the women. I know that's not, I'm not trying to be sexist. It's just what we've all been conditioned to. So let's go, so this is pink, let's go okay. Oh, I turned yeah. Okay, now let's go with males. Same thing. Text that contains. Yep. Specific text containing capital M. It's custom format. Let's make this light blue. And the font, I don't want that red color. Let's make that dark blue. Or just blue. Everybody with me? Hit OK. And OK. Interesting. Yeah, I would say, yeah, there probably is a little more males. But again, once we get the jump software, we can figure out if this is actually more than what we would expect by random chance. So let's maybe, yeah, it'd be so nice to have that statistical software now. I know. How about content or tactile content? Let's format this while we're thinking about it. So let's make, so remember, highlight cell rules, text that contains Y. So yes, we'll make that green. So custom format, make the color green. Actually, you can make the font can be black. Let's make the fill green though. Some kind of green. Ooh, lime. Or seafoam. Who wouldn't want seafoam? Now let's go lime. Okay. Okay, doing N. Let's go. No, we'll make those red. Custom format. And make sure the font is black so we can see it. All right. So here, what we will do is eventually, once we get the statistical software, is what I'd like to do is say, okay, if you got within 10 pounds, so how many people were 10? 36? 36 individuals got close enough within 10 pounds of the actual weight. If there was 36 people and this was just random, given if they're male or female, and that had no effect on their guesses, how many males and females just randomly we would expect in this group of 36? You understand what I'm asking? That given the fact that, we already know that there's effect with males and females, right? But say that we don't know that yet. That if we looked at these 36 genes, these 36 guesses that were within 10 pounds of the actual weight, how many, if there was no effect of gender, how many females would we expect? How many males would we expect? Yeah, totally. Same way with tactile contact, right? If touching the rock made no effect, then we would expect about 18 and 18. Do you think it would be exactly 18? No. It's just like flipping a coin, right? That, I can flip a coin 36 times. I guarantee you, odds are it's not going to be 18 heads versus 18 tails, right? It's going to be close to that, and that's what we can do. So eventually what we're going to do once we get the software is we're actually going to test some of these things. Is, given the fact that these people are so accurate, was the fact that they actually touched the rock, did that make a difference? The fact that they touched the rock and were males. There's a lot of different things that we can look on this. There's also things we can sort by date, right? I have a feeling that the measurements we got better guesses the longer we were doing this survey, right? So theoretically, we could actually start looking at the median guesses for everybody per day and see if they actually decrease. You see what I'm saying? So here's what I want you to do. Until we get the JUMP software, what I'd like you to do is just kind of play around with the data. Start making, graphs like this. Because here's what your assignment's going to be until the end of February. Is what I want you to do is basically analyze the data set. Find interesting things. You don't necessarily have to prove anything. Just find very interesting trends. And when you find an interesting trend, make a graph that kind of demonstrates that point. That if you said, you know what, I think age is an effect, you basically want to give a graph like this to say, hey, look, all of these guesses are all over the place, but as these people get older, these are starting to regress towards the mean. So age does play a huge role. Where is that point where maybe, people are more accurate? What else could we do? Or you could say, hey, let's look at the males. Just the males that actually touched the rock. Were the males that touched the rock, because we kind of had that theory or that hypothesis that those people that touched the rock who were younger and couldn't lift it up made really wild, inaccurate guesses. But those that were older, maybe they actually, so we could basically do the same thing as this graph, but just limit it to the males and those that touched it, right? You can analyze this in many, many different ways. And basically what I want you to do is, you don't have to, don't treat this as an assignment right now. What I want you to do is just kind of go through this data and just get a feel for it. And I do this with gene expression stuff all the time. When I'm doing an experiment, the most important part is just to get a feel for the data. Just kind of comb through it, not try to get answers. And then all of a sudden you'll be looking through it and just this something will pop in your head, and it almost knocks me down sometimes. I'm like, of course, and it'll just come to you. What you kind of want to do, and what I'm trying to teach you here, is that, get comfortable with the data. Organize it any possible way. There are no rules. And I say that with complete confidence because, the stuff I do with gene expression stuff, no one else is doing. And they always tell me I'm wrong, and I'm like, no, I'm not. So basically explore the data set. Let's figure out what's going on. Just start collecting some of these graphs. If I have this graph here, what I can do is I can save as a picture and just start saving some of those. So I can save as a picture. Start giving yourself a folder and just start putting these graphs. Or actually what we could do, I think it would be better if you start a PowerPoint. So here's what I'm going to do. I'm going to copy this and go to a PowerPoint. This is my this is my day job. Give me a new one. Yeah, you will never be done giving presentations, people. I will tell you that right now. We can just click on this. We can make this a blank slide. And just paste. Oh, there it is. Okay. And now you can, in the notes section, this is what I recommend you guys doing. Go in the notes section, say how you did it. We did XY plot. Or actually it was scatter, what was it? Scatter plot? Scatter plot of age versus predicted minus actual. There seems to be an age effect. Older, more accurate. Because here's what we're going to do. You know that wisdom of crowd things that I gave you? We are going to write a paper basically for the month of February. We're all going to contribute. So that means we're going to need lots of results, and we'll have to talk about them. And if it's good enough, I guarantee you I will try to submit it somewhere, and we will get it published. I think this is really cool data, especially once we get the jump going. So until we get the statistical software, just go ahead and play with the data, guys. Do this, mash it up any way you want. There is no pipeline. There's no rules. There's no instructions here. Just have fun. All right.